Hello students, welcome to Saurav Sir's classes. This video is Matrix video part 7, and in this video we will learn about the inverse of a matrix. Its definition is given by A is a square matrix of order n is invertible if there exists a square matrix B of same order such that AB is equals to In is equals to BA. In such case, we say that inverse of A is B, and we write it as A inverse is equals to B. Now there are some useful theorems on invertible matrices. The first theorem states that a square matrix is invertible if and only if it is non-singular. Now, let A is a square matrix which is invertible. That is A is invertible matrix. Then there exists a matrix B such that AB is equals to In is equals to BA, where A and B are matrix of order n. So this implies mod of AB is equals to mod of In. This implies mod of A into mod of B is equals to 1, since determinant of identity matrix is 1. And since mod of A into B is equals to mod of A into mod of B, so we get this. From this we can say that mod of A is not equals to 0, which will imply that our A is non-singular. Now let A is a non-singular matrix of order n. Then from the previous theorem we can say that A into adjoint of A is equals to mod of A into In, which is equals to adjoint of A into A. This implies A into 1 by mod of A into adjoint of A is equals to In is equals to 1 by mod of A into adjoint of A into A. Now, by definition of inverse, we can say that A inverse is equals to 1 by mod of A into adjoint of A. Now if we have A is equals to AD, ABCD, where AD minus BC is not equals to 0, then we will have our mod of A is equals to AD minus BC, and adjoint of A is equals to DA minus B minus C. So our A inverse would be equals to 1 by AD minus BC into DA minus B minus C. Next theorem, which is the Theorem of Cancellation law, states that if A, B and C are square matrices of same order n, and if A is a non-singular matrix, then if AB is equals to AC, then this would imply B is equals to C. Now this is left cancellation law. And second is, if BA is equals to CA, then this will imply B is equals to C. This is right cancellation law. Note that AB is equals to AC will imply that B is equals to C. Now this will be true only when mod of A is not equals to 0. And if mod of A is equals to 0, then there may exist cases where AB is equals to AC, but B is not equals to C. For example, if A is equals to 1, 2, 3, 6, here mod of A is equals to 6 minus 6, which is equals to 0. Now let B is equals to minus 2, 0, 0, 0, and C is equals to 0, 0, minus 1, 0. Here B is not equals to C, but we will get our AB is equals to minus 2, 0, minus 6, 0, and AC is equals to this and this. Again minus 2, 0, minus 6, 0. So our AB is equals to AC, but B is not equals to C. Next theorem is the Theorem of Reversal Law. It states that if A and B are invertible matrices of same order, then AB is invertible with AB inverse is equals to B inverse into A inverse. Similarly, if AB are three invertible matrices, then ABC inverse would be equals to C inverse into B inverse into A inverse. Now let us prove it. Now according to the definition of inverse of a matrix, we have AB into AB inverse is equals to I. Now multiplying both sides by A inverse, multiplying both sides by A inverse, we get A inverse into AB into AB inverse is equals to A inverse into I. Now this implies A inverse into A into B into AB inverse is equals to A inverse. Since A inverse into I is equals to A inverse, so this implies I into B into AB inverse is equals to A inverse. This implies B into AB inverse is equals to A inverse. Now multiplying both sides by B inverse, both sides by B inverse, we get this is equals to B inverse into B into AB inverse is equals to B inverse into A inverse. This implies AB inverse is equals to B inverse into A inverse, as B inverse into B is equals to I. Next theorem states that if A is an invertible matrix, then its transpose, that is A transpose, is also invertible matrix, and A transpose inverse is equals to A inverse transpose. Next theorem states that if A is a non-singular matrix of order n, then mod of adjoint of A is equals to mod of A raised to the power n minus 1. Now from previous theorem, we have A into adjoint of A is equals to mod of A into I, which is equals to mod of A, so on, mod of A 0, 0, 0. So A into adjoint of A is equals to this. Now taking determinant both sides, we get determinant of A into adjoint of A is equals to determinant of mod of A, so on, and other values are 0. Now, this is an n cross n matrix, so this would be equals to, now mod of A into adjoint of A is equals to mod of A raised to the power n. Now we know that mod of AB is equals to mod of A into mod of B. Therefore, this is equals to mod of A into mod of adjoint of A is equals to mod of A raised to the power n, which implies mod of adjoint of A is equals to mod of A raised to the power n minus 1.